Hello, good morning everyone. My name is Sławomir Zieliński. Welcome to the Sunday morning's session. We will have 5 presentations during this session, and the first one is authored by Deputy Takar, Mr. Roy and Professor Chaki, and is entitled TOMAI, a token-based fair mutual exclusion algorithm for inverted tree topology. The authors are from India. And now let me ask whether Mrs. Debdita Kar is with us remotely. Mrs. Kar, are you with us?
Yes, sir.
Is it okay? Can I ask you to switch on the camera so that everybody can see you?
Yes, sir.
All right. Welcome. In a moment, we will play back your presentation, which has been pre-recorded, and after which we will give you an opportunity to answer any questions that will be asked by the audience. Is it all right with you?
Okay, sir.
Okay, so let's listen to your presentation.
Hello, everyone. Today I will be discussing TOMAL, a token-based fair mutual exclusion algorithm. These are the contents that we are going to discuss today, that is motivation, literature review, key features, block diagram, example, experimental section, conclusion, and the references. TOMAL is a distributed mutual exclusion algorithm that ensures safety and fairness. Also, the data structure used is simpler when compared to other similar algorithms. A large number of mutual exclusion algorithms for distributed systems have been proposed over the years. There are both centralized approaches and distributed token-based approaches. Raymond's algorithm is a tree-based distributed mutual exclusion algorithm that uses tokens for resolving the conflict between the sides. In Raymond's algorithm, fairness is not assured. This is because this algorithm stores the identifier of the nodes that request to enter the critical section, but it never stores the order in which the request arrives. So even though all the nodes that request the critical section gets it, but the order is not maintained. The problem of ensuring fairness for mutual exclusion algorithms for distributed systems has drawn considerable attention over the years. There have been attempts to overcome this deficiency. We have observed that the authors of MRAP and an efficient and fault-tolerant solution for distributed mutual exclusion have proposed a modified Raymond's algorithm that solves the fairness problem of Raymond's algorithm. Though modified Raymond's algorithm solves the fairness issue of Raymond's algorithm, the storage complexity for MRA is quite high. The algorithm does not only require more storage but also some additional processing time. In an efficient and fault-tolerant solution for distributed mutual exclusion, authors proposed an efficient and fault-tolerant algorithm for generating the quorums to solve the distributed mutual exclusion problem. The request sets are formed based on a binary tree configuration of system sites. Sites are logically organized as a binary tree, and the request set of a site contains all the sites on a path from the root to the leaf containing that node. However, the algorithm violates the spirit of equal responsibility because some sites appear in more request sets than others. TOMAL, the proposed algorithm. What we proposed is a distributed mutual exclusion algorithm that ensures both fairness and safety, and also reduces the storage complexity. The algorithm uses two types of data structures, namely queue and variables. Each and every node has a local queue to keep track of all the requests and a local variable to keep track of to whom the token needs to be returned. The algorithm is divided into three modules. namely the request token module, the token passing module, and the token receiving module. The first module is the request token module. Whenever a node wants to access the token in order to enter the critical section, it generates a request. This request is forwarded to the node with the token. The second module, named token passing module, is invoked when a node comes out of its critical section. After coming out of the critical section, a node checks its local variable and the local queue and forwards the token accordingly. The token is passed to the nodes that requested to enter the critical section in the order of the request. The last module is the token receiving module. Whenever a node receives a token, it checks whether the token needs to be returned or to be passed forward. If the token needs to be returned, then it returns the token, otherwise forwards the token to the node that requested for the critical section. Let us consider a tree to understand the algorithm. Now, to understand the algorithm with an example, let us consider an inverted spanning tree. The node A is initially holding the token and is in critical section. After process A comes out of its critical section, it checks its local variable, which is empty. So next it checks its local queue. The first element or the first process ID in its local queue is C. So A passes the token to C, adds its own process ID to the local variable of C and inverts the edge in between A and C. In this situation, the C which is present in the local queue of A is deleted. Then C executes its own critical section. After C comes out of its critical section, it checks its local variable and therefore returns the token to A. Then the local variable of C becomes empty and the edge in between A and C is again inverted. Now when A gets the token back, it checks again its local queue and sends the token to B. Here B is executing its critical section. After B comes out of its critical section, it checks its local variable that contains A and so returns the token to A. After A gets the token, it again checks its local queue which contains C. So it sends the token to C. Then C checks its local queue which contains F. So C forwards the token to F. F enters its critical section and after it comes out of its critical section, it checks its local variable that contains nothing, which is actually empty. And now F has got no node to send the token forward to. So F keeps the token with itself until further requests. The algorithm is evaluated against some randomly generated spanning trees to check whether the fairness is ensured in all possible conditions of request generation. A connected graph with n nodes is produced by the system. Considering any one of the nodes from the n nodes as the initiator or token holder node, a spanning tree is generated. Then requests for token are generated by all the other nodes in the spanning tree in different possible ways. The order of execution of critical section, the status of local queues and the local variables by the nodes are recorded by the system. The recorded data are analyzed for any inconsistency in the execution. This process is again repeated by selecting another node of the graph as initiator and building a different spanning tree from it. We have repeated the same process by building n different spanning trees from the graph. This process of evaluation is used to ensure that the algorithm satisfies fairness for different possible ways of token request generation. Thus, we may conclude that the main contribution of this work is in proposing TOMAL, a new token-based mutual exclusion algorithm that ensures fairness in serving the token request of the nodes. We have used a very simple data structure for the implementation of TOML. The proposed algorithm also complies with the two constituent elements of correctness, namely safety and liveness. The existing MRA approach offers a priority-based token assignment. This is beyond the scope of TOML. However, the storage complexity of TOML is lower as compared to the MRA algorithm. We have also evaluated our approach by implementing the algorithm against different randomly generated spanning trees of random sizes. Thank you for your valuable time.
Thank you very much for your presentation. Now it's time for questions and answers. First, let me ask the audience who is present here on site. Do you have any questions to the presenter? Oh, there is one.
Well, thank you very much for a really interesting presentation. However, I have one question, because you said that you have compared your algorithm with those that were presented in the literature. However, did you also compare it with those that are practically used, like JSON Web Token, for example?
Can you repeat which algorithm?
With JSON Web Token.
No, I haven't compared it.
Okay, thank you very much.
Any other questions from the audience on site? Any other questions? Okay, maybe there are some questions from the participants, remote participants. If there are any, please raise your virtual hand and indicate that you want to ask a question. Okay, okay. Professor Said has a comment, so please.
Thank you very much. Thank you. I can see also Professor Chaki is there. Hi, Nabandu. I hope you are doing very well. I have a comment to the question actually asked by Maciek. Why you asked about this algorithm?
Well, because it is one of the most that are practically used. Also in practical solutions, especially, for example, in web applications. So it is why I asked about the comparison, and it is really efficient algorithm. So it is why I asked.
So this is a good comment for her to consider for future, so that we can explain. Okay, thank you.
Okay. If there are no other questions.
May I add?
Yeah, Professor Chaki. Yes, please.
Dzień dobry. Hi Khalid, thank you. And Khalid's question remind me of typically Cisim spirit. Nobody is safe there. So I'm missing the physical participation. That's what I wanted to communicate. Thanks to all of you that still you organize this conference and it's being held in the proper spirit. And thanks for accepting our work. Thank you.
Thank you very much for participating, and it's really great to have you here. And as I mentioned earlier, the presenters are from India, from Calcutta University, and it's great to have you here. So let's move on to the second presentation, which, in the meantime, can I ask you to mute your microphones? Can I ask the remote participants to mute the microphones? Thank you. Okay, the title of the second presentation is a novel proposal of using NLP to analyze IoT apps towards securing user data. And the paper will be presented by Mr. Raghunath Maji. The paper is co-authored by three scientists from AKC School of Information Technology, Calcutta University in India, and Maulana Abul Kalam Azad University of Technology, West Bengai, Kolkata, India. Now, Mr. Maji, are you with us? I can see you. Can you hear me? Mr. Maggi, can you hear me? I think that there may be some technical problems.
Yes, sir.
Okay.
Yes, sir.
Great. First,
Yes.
we will watch your presentation, which has been already recorded. And similar to the previous presentation, after we have watched the presentation, we will give you an opportunity to answer the questions. So let's watch the presentation.
Good morning, everybody. First of all, we feel gratitude to Cisim. Cisim is going well successfully in its 20th international conference. I am very happy and very lucky being a part of this beautiful platform for the researcher. Myself Raghunath Maji. Today I am representing my paper, a novel proposal of using NLP to analyze IoT app towards securing user data. My research guide cum co-author Professor Ritu Purnachaki from Calcutta University and Assistant Professor Dr. Atri Biswas from Maulana Abul Kalam Azad University of Technology. The outline of our presentation are significance of app security in IoT environment, then review work, then research gap, our contribution, conclusion, and references. Significance of app security in IoT environment. The application of IoT cover almost all the facets of human existence. So, use of IoT device is also growing in all the area, and unfortunately, it made IoT device a continuous target of cyber attackers. One of the prime way to data theft from IoT device are overprivileged apps. In all the application of IoT, the IoT apps play the role of enablers of the IoT services, from education system to healthcare system, financial service to smart farming. Everywhere we take help of various applications which facilitate user to get smooth services. The installation of any app require the series of the installation of any app require the user to agree to a series of permission. Generally, the user have no time to get through this lengthy document. And they agree to them immediately without much thought. And the app take more permission that actually no need for their work. These overprivileged apps have the chance of turning security breaches. Here we see one example, the app called the One Calculator. This app is commonly used for calculation purpose, but here it is seen that this app is asking permission to manage our contact, which is malicious activity, and this app is malicious app. Next, target and action of malicious app. The main goal of malicious app is to steal the important data from our endpoint device or endpoint IoT device and damage the device. Next, bypassing detection during evaluation period in Google Play Store. We download the app from Google Play Store and Google also check if the apps are corrupted or not. So the question is, Why we doing this? The answer is the attacker already have some technique to bypass the Google authentication, and two techniques of which are see here. These both are the technique for bypassing the Google authentication. Next, the review work. Now coming to some review work. In this paper, the author tried to identify the malicious application by using user review. But they have a drawback. They assume all the reviewers are credible. If the reviewers are not credible, then the model result will not be accurate. And next paper. Here in this paper, the author depend on only the user review. Same thing here. So the problem is same. In the third paper, the author proposed a method and they check the app behavior using app description. But the app description is collected from the Google Play Store, and the description of the app in Google Play Store has a character limit. Thus, it does not describe the behavior of an app details. Then coming to our research gap. The context analysis of app description play significant role in accurate interpretation of the intention of an app. Unfortunately, this aspect is mostly missing in this review work. Mostly previous work use user review for finding app behavior. But if the reviewer is not trustworthy, then model result will not be accurate. It is also observed that the previous work considered app description for identifying app behavior. However, due to the character limit of Google Play Store, the description of app may not contain the detailed information. Towards bridging the gap, we proposed a framework for detecting malicious app in IoT context using combination of different NLP technologies. In our framework, we used privacy policy from original website that cover full description of an app. Here we used an advanced tree-based technique called isolation forest for outlier detection, and the complexity of this technique is linear. This is our proposed system architecture. There are the 5 main stages: pre-processing, topic modeling, API analysis, clustering, outlier detection. Let us describe one by one. Pre-processing. During the pre-processing phase, we download the privacy policy from the app website. Next, we next is text cleaning. Here we collect only the English word and eliminate all space and stop word, article, preposition, etc. And next, use lemmatization to find the root word. This is a screenshot of text cleaning. Here we have tried to show user how to clean the text using Python language in our framework. Here we try to show how to find the root word using lemmatization technique in our framework. Here we for topic modeling we use LDA2VAC technique, and we separate the app into some group. This is the topic modeling screenshot. Manifest.xml file. For API analysis, we use manifest.xml file. Without API call, no app can send or receive data from outer world. In case of Android, all API are must describe in manifest.xml. So we extract this file from Android APK. Next. Fetch permission details. We extract all API details or all API permission details from this XML file. This is one screenshot of that. Here we fetch only the permission details using Python language. Sensitive permission. In Android system, there have a lot of API permission. From this, some of is very sensitive, like read contact, write contact, manage contact, read SMS, write SMS, send SMS, camera, record audio, outgoing call, etc. Then finally, we have used a tree-based anomaly detection algorithm technique called isolation forest to detect the overprivileged app. This is the screenshot in our framework how we are finding the overprivileged app. Next, coming to conclusion. In our framework, we have used privacy policy for malicious app detection, which solved the Google Play Store word limit issue. Next, most of the previous work used SPM technology for outlier detection, whose complexity is order of n cube. In our case, we use isolation forest, whose time complexity is order of n or linear. In submitted version, we only propose the framework. But in this presentation, I like to show the experimental result following the framework in a small scale. We are still working on it to apply in a large data set. These are reference to all the paper I have used for review work. And thank you.
Mr. Maggi, thank you very much for sharing with us your research outcomes. Now we've got time for one question. Please, first let me ask the audience who is present with us physically on site. Do you have any question? Yes, there is one from Professor Said.
Not a question, just Professor Tuparna-Chaki. Hi, Mrs. Professor. Thank you very much for joining us.
Thank you.
Thank you very much. Of course, as I mentioned in my word at the opening of the conference, Mrs. and Mr. Chaki are from the beginning with us, from 2008 are with us with the Cisim conference. Their contribution always is of very high quality, and thank you very much. Thanks. Thanks to you and your PhD student.
Thank you,
Very
sir.
good presentation. Thank you.
Thank you very much.
Jinklang Warjo, sir.
Okay, maybe a question related directly to the work which has been presented. Is there any question? No, I can't see any questions. So, Mr. Maggi, thank you very much, and let's move on to another paper which has been co-authored by 3 researchers from Korea, Mr. Kyayo Man, Professor Ling Tong Zhang, and Professor Yang Im Cho from Gakon University, Sangam, Korea. And the title is very intriguing: Efficient hair damage detection using SEM images based on convolutional neural network. Now, the paper will be presented by Mr. Kyayo Man. Mr. Man, are you with us? Mr. Man? Mr. Man, can you hear me? It seems that he's either facing technical problems or hasn't connected. Nevertheless, I think we will be able to listen to his presentation, which has been pre-recorded. So if we can launch it.
Hello, my name is Chen Weilman from Kansas University in Korea. Today I will introduce your paper, which is called Efficient Hair Damage Detection Using SEM Images Based on Convolutional Neural Network. I will use the following 5 parts to introduce. First, the introduction, related work, proposal method, and the results and conclusion, with people becoming more and more interested in hairstyle and hair color. Hair is easy to cause damage under the influence of chemical agents and physical switching, and the damage degree of hair can only be measured by naked eye outputs, which can't accurately quantify and the damage degree. We created a new hair damage dataset based on scanning electron microscope images through various frequent critical analysis. We observe the change in the hair surface according to the degree of hair damage, found the relationship between them, and use intelligence the convolutional neural network recognized and confirms the degree of hair damage and divided the damage of degree of damage into weak damage and high damage. In this paper, we proposed a testing network based on AI algorithm, which is used for scanning electron microscope hair surface image damage to automatically identify and divide the damage. In this paper, we created a new hair microscope dataset based on SM image data and performance quantitative analysis to classify the degree of hair damage according weak damage and hair damage, we proposed a new convolutional network for hair damage detection as a SANet special autism convolutional neural network. We designed and introduced a special autism model into the hair damage detection model to get hair feature to improve the accuracy of detection and recognition. Hair macro detail detection and recognition can finally use in many disciplines such as medicine and forensics in the connect of forensic science. Microscope analysis has so effective discrimination and detailed examination of hair, and the microscope is helpful to forensic identification. Microscope analysis can be used as a tool to assess hair damage and linked to hair issues, but the analysis need to be performed under certain detections. Hair is subject to various physical and chemical agents, including agents that coming and ultraviolet rays, which will change the structure of the hair. However, there are few studies to quality and the degree of hair damage based on the morphological characteristics. ResNet. ResNet introduced a residual block in the traditional convolutional neural network and somehow context mapping layer on the basis of network for performance residual lane, which improve the accuracy of deep features is extraction and through the program of according to this properties. ResNet consists of many stick residual units. We proposed as a network special autism convolutional neural network is based on the ResNet, and this work from work we design a special autism model and add it to the study model to efficiently focus on hair damage features and improve detection efficiency. But the residual convolutional network is used to process the SM hair microscope data after layer convolutional processing. The hair features map is generated after that. The hair features map in the special autism model we design focus on hair damage filter and despite the detailed filter of the hair damage that are inserted. Autism model when processing hair CM microscope immediately due to small difference in hair surface characteristics. Ordering algorithm model can't accurately identify the some difference in hair damage. In this paper, we designed a special attention model suitable for hair microscope image to improve accuracy of higher image. Higher SEM microscope imaging detection and damage filter identification. We collected hair sample of men and women in the 20 to 15 5 age group and using Hata's S 4700 scanning electron microscope to generate the hair microscope images. The damage to the hair observed under scanning electron microscope is divided into three weak domains. Elements. We use the data enhancement algorithm to enhance the collected hair SM image. For example, we use the image emission, rotation, cropping, in cushion noise, and another algorithm. We created a hair SM dataset that had a total of 15 thousand microscope hair images of various types, containing 5,000 microscope images of weakly damaged hair, 5,000 microscope images of damaged hair, 5,000 microscope 5,000 microscope image of hair damaged hair. In the experiments, we divided the data into twin data and test data. Twin data and test data. 18% is as a twin set, and 20% as a test set. Crop the image size to 4 by 2 to 4 using center cropping. The network is trained using SGD algorithm and set lane rate to 0.1 and use negligible momentum of 0.9. We selected another excellent network model to compare with our all-purpose model, and use the SEM-based hair microscope dataset we created to detect the accuracy of the algorithm. Using X9, VGG 16, equation within 4, or equation within 3, member net, less net 15. We propose the model as a net. Our proposed model compared with another model have better accuracy. These people will create a high dataset on SM microscope and developed classification based on the degree of hair damage. For the dataset, we also proposed a no residual convolutional neural network based on the special Cisim model and verified it with our dataset. The experiments so that our network model is efficient and robust. We focus on how to detect damage automatically and efficiently. We created a system based on AI convolutional neural network that should also detect and degrade of hair. That means. Okay.
Okay. Thank you very much. In the meantime, I was told that Mr. Mann had joined us remotely. Mr. Mann, can you hear me? Mr. Mann? Mr. Mann, if you hear me, please indicate this. Mr. Mann, are you with us? Are you able to answer any questions? Okay, Mr. Mann, can you hear me? Mr. Mann? There may be some technical problems. Mr. Mann, can you hear me? Okay, if not, if there are any questions, please send any comments, suggestions, or questions directly to the authors. Okay, thank you very much, and now let's move on to the next presentation. And the paper is authored by 7 scientists from Białystok University of Technology, Poland, namely Michał Czołąbitko, Tomasz Grześ, Maciej Kopczyński, Urszula Kurzelewska, Anna Łupińska-Dubicka, Dorota Mozyrska, and Joanna Panasiuk. And the title of the presentation is Development of Digital Competences of Elementary School Teachers with Lifelong Learning Approach. And the paper will be presented by Dr. Tomasz Grześ. And as usually, first let's watch the presentation and then we will have a chance to discuss the topic with the author.
Hello, my name is Tomasz Grześ, and I am going to summarize the researches on development of digital competences of elementary school teachers with a lifelong learning approach. The authors of this research are Michał Czołąbitko, Tomasz Grześ, Maciej Kopczyński, Urszula Kurzelewska, Anna Łupińska-Dubicka, Dorota Mozyrska, and Joanna Panasiuk. The plan of this presentation is as follows. First, I will tell about the project Programming from Scratch. Then, I will show researches and the methodology used during the researches. Next, I will show the results of our researches. Finally, the conclusions and future work will be described. This paper is summarization of the project, Programming from Scratch, Development of Digital Competences among Teachers and Students of Grades 1-3 of the Białostocki and Sokolski countries. The project was implemented thanks to the European Union Structural Fund from the Digital Poland Operational Program 2014-2020, Measure 3.2, Innovative Solutions for Digital Activation. As we know, digital competences should be developed as soon as possible, as less age of pupils as possible. So the main aim of the project was to support development of competences in teaching programming basics and to create conditions for introducing programming to primary school students aged 6 to 10. Research was performed in 2 counties, Białystok and Sokółka County. So the research was limited geographically, but more than 140 teachers of primary schools took part in this study. So the group of the teachers was quite big. Training in programming techniques was performed for teachers of public schools, but also employees of public libraries and cultural institutions. So the wide group of people involved in teaching pupils was included in this program. The main result contributed to increasing the activation of people's basic digital competences and the development of digital competences. Additionally, teachers were also supported with the necessary teaching aids. These aids include mobile devices, tablets, educational robots, and educational math. So teachers in future can use them in their lessons. Planned objectives was achieved by implementing the following tasks. First, we recruit project participants focusing on teachers of primary schools. Then we conduct initial analysis of digital competences of the project participants. These results of this analysis was used to determine how to conduct the classes. In meantime, we purchased the necessary equipment such as tablets, robots, and educational math. Then we organize specialized training of activities. This training was necessary to prepare teachers to perform classes using the equipment purchased earlier. To teach the teachers, we conduct the first stage of training and other adults in selected schools. After this training, the teachers were ready to perform classes, so we recruit children for additional classes with teachers, and then we develop primary balance of competences of children in cooperation with teachers. This preliminary balance started the second stage of teachers' training. This training starts with practical classes with students, of course with consultation and help and support of the trainers. One of the classes were performed outside the place of training at the Faculty of Computer Science out of the Białystok University of Technology. A final competences assessment was performed at the end of the course to test, to verify if the students was developed their competences. At the end, we summarize the training results. Methodology assumed that teachers conduct the classes using the developed set of scenarios focusing on educational math. This math was from the Masters of Coding. The educational robot, this was photon robot, and some applications for children, such as Scratch, Scratch Junior, and App Inventor. Authors prepared 6 scenarios for the math, 11 scenarios for Photon, 8 scenarios for Scratch, 4 scenarios for App Inventor, and 6 scenarios for Scratch Junior application. All teachers involved in the project had personal training regarding all mentioned tools and scenarios during the group weekend sessions, where each session was devoted to a different subject. Next step was teachers' personal involvement in the project. Every teacher had to perform 30 hours of classes in the group from 10 to 28 kids. Of course, each teacher had a personal trainer supporting for 10 class hours. At the beginning of this course and at the end of this course, authors perform the study on competences of teachers and so we have initial shown in this graph in green and final shown in blue competences in Białostocki and Sokolski counties. Of course, you can easily see that the competences rise after the course. As the set of competences is divided into 5 groups, it is worth checking whether there is any correlation in raising competence in different groups. To observe these correlations, we introduce the rise index of the competence that is shown in presented formula. In this formula, K means a county. County could be Białostocki County, Sokolski County, and both counties to show total or correlation of all teachers. I is a number of group of competences. Then CBKI is the level of competence at the beginning, and CFKI is the level of competence at the end of training. In this table, we can observe that the lower values of coefficients could mean that the competences among teachers involved in the project from Białostocki County are more scattered, and in post-questionnaires they showed learning in different directions. In all tables, it is seen that the highest correlation was diagnosed between the information and communication group. Moreover, all coefficients are positive. The latter is important to be stressed and means that the rising of the group competences causes a rising of the other level. The rising ratio vectors were used to create again box plots for different counties, Białostocki County, Sokolski County, and both counties together. It is seen that in all figures the median remains at similar level, about 50%. The third quartile for teachers from both counties is slightly less than 100% for competences such like information, communication, security, and troubleshooting. For content creation competency, at least 75% teachers from the project raise their skills to more than at least 100%. It is worth observing also that there are results much more higher than the other, hence teachers who raise their competence to about 500%. Conclusions. All assumptions based on the project were met. All teachers and all pupils that took part in the project showed that their digital competences have increased. To generalize the project results, introducing digital competences from early education builds the strong hope that the outcomes will have a significant impact on the future evolution of young digital generations and their teachers. Future research will focus on the examination of the increase of the children's competences in computational thinking, design thinking, problem solving. Thank you for your attention.
Thank you very much. Now we've got one of the authors here physically present with us on site, Dr. Tomasz Grześ. Now there's an opportunity to ask a question from on-site participants. Yes, Dr. Kopczyński.
Thank you, Tomek, for sharing the results. I was also involved in this project. Maybe this will not be a direct or strict question, but a quick comment. I think that the best measure of the project that we have made for the 3 years, as I recall correctly, the part of the project was related of buying some hardware. So there were 40 robots and, as far as I recall, 80 tablets. And all of those devices were given back at the end of the project to the schools that participated in the project, and most of them are in use in day-to-day basis by the teacher that were involved in the project. So I think that if we forget about all the graphs that Tomasz has shown us, so one of the best measures is that the results of the project are implemented on the day-to-day basis of the elementary schools.
Thank you, Maciej. Exactly, and I would like to add that I can observe the results of this project because I am involved also in conquest, computer science conquest for pupils in Białystok. So contest. So I see the progress in programming competences among students of elementary school. It is very big progress in the period of about 5 years. So I think that this is also very great example and proves that this project was a very good thing for our city and our country.
Okay, thank you. Any other comment or question from the on-site participants?
Maybe from me. What was the biggest challenge during working with such small children?
I think that there was no problem because the children, the small children, are very interested in discovering new things. Robots, photon robots, because they are very, I don't know how to say, nice. They are beautiful. They are colorful. Children, when saw these robots, were ready to start teaching. Also the maths, tablets, because children knows very good such devices. The problem was not with children, but with the teachers, because a lot of teachers have problem. This is a very big gap, technological gap between children and teachers, especially older teachers.
Okay,
thank you.
Before we move on to the last presentation during this session, let me ask the remote participants. Do you have any comments or questions? If so, please raise your virtual hand and indicate this. Okay. If there are no questions, let's move on to the... Yeah. Thank you. Let's move on to the last presentation during this morning session, which will be given by Mr. Aleksander Sawicki. And the topic is augmentation of gate cycles using LSTM MDN networks in person identification system. And as usually, first let's watch the presentation and then we'll have question and answers time.
Good morning, ladies and gentlemen. Let me introduce myself. I'm Aleksander Sawicki from Department of Digital Media and Computer Graphics, University of Technology, Białystok. The subject of my presentation is augmentation of gate cycles using LSTM MDN networks in person identification system. The presentation includes the following sections: motivation, methodology, results, and conclusions. The motivation for the study is contained in 3 main points: building a gate-based behavioral biometric system, construction of system based on accelerometer measurements, and evaluation of the possibility of using LSTM MDN networks for gate cycle augmentation. In the presented study, we used a publicly available human gate dataset established in 2020. The following slide provides its short summary. The most important indicators include 30 participants, 1 motion tracking session per person, and 6 trials per motion session. Human motion was acquired as block recordings containing many repetitive gate cycles. The proposed data processing pipeline result in a total of about 2000 segmented gate cycles. The photo on the right shows the location of each of 6 available sensors. In our work, we focused only on person identification, based only on the accelerometer attached to the right cuff. As the input data was provided in the form of block recordings, an algorithm for segmentation of individual gate cycles was implemented. For this purpose, a 2-step method was proposed. In the first step, only periods of movement was extracted, while in the second step, proper starts of each gate cycles was detected. The current slide shows the result of each step of the proposed segmentation algorithm. The current slide compares the gate cycle extracted from the proposed pipeline and the signals presented in the literature. From the presented graphics, it can be seen that the z-axis signals closely follow the nature of the plots in scientific publication of other authors. The z-axis signal begin and end with a negative impulse. It marks the touching against the ground of the leg equipped in the sensor. At the same time, it should be noticed that this moment starts the stance phase of the gate cycle, whereas the oscillation in the middle part of the cycle comes from the second leg hitting the ground. Moving on to the actual topic of data augmentation, we can point out at least 3 desirable features of good augmentation algorithm. The new generated samples should not duplicate the original data. They should, however, represent observable signals. What is very important is that the new samples should have the features of the original data. The classifier should give them the correct label. Satisfying the last criterion is especially difficult in the case of gate cycles. Presented figure shows a motion signal collected from 2 different participants. As we can see, the signals are very similar. In such a case, adding too much variance to the original data can be harmful and stops the classifier from being correctly trained. In our study, we implemented one of the classic gate cycle augmentation mechanisms. Current slide shows step-by-step algorithm description as well as figure in which 200 augmented samples are presented alongside the original motion signal. In this study, we proposed the use of LSTM-MDM models for data augmentation. We focused on these models due to the fact that the literature describes a handwriting generation experiment involving them, and the LSTM component is able to extract the historical features, but is deterministic in this nature. And the MDN component provides the ability to generate an arbitrary number of new data due to modeling the distribution parameters. In proposed approach, we applied the measurement values of 60 samples length, 3-axis accelerometer to the input of the network. The first part of the model contained a decoder of 2 LSTM cells that act as a feature extractor. Thanks to the application of the MDM layer at the output of the model, we obtained not a single time series but Gaussian models described by expected value and standard deviation. On the current slide, 200 predicted time series are presented alongside the original motion signal. We can observe that the variance is selected individually and takes relative small values in the middle of the gate cycles. More variability is observed at the oscillatory fragments. Moreover, a separate generative model was prepared for each of the research participants, so the variance level was added individually for each of them. After the prior segmentation and augmentation of the signals, the person identification process was performed. In the classification task, we used a recurrent LSTM neural network. A 6-fold cross-validation repeated 90 times was used to evaluate the quality of the biometric system as well as augmentation method. In the table presenting the results, we can notice high identification rates. In each of the cases, the baseline, classical augmentation, LSTM, MDN augmentation, the mean performance exceeds the value of 0.94 f-score. Moreover, in 5 out of 6 validation sets, the proposed methods achieved better identification rates than the classic one. Moving on to the summary. The developed biometric system had a high performance of 0.96 f-score in the case of data augmentation. The classical augmentation method marginally increased the score of the identification process, while using the proposed LSTM MDM methods increased the average score by 2 percentage points. Finally, it should be pointed out that the use of an intelligent augmentation method that enables the generation of perturbation with different levels for each participant as well as each fragment of the gate cycles can give better results than the classic simple methods. In conclusion, I would like to mention that our future work will concern the use of the authors database, which is described by metrics such as 100 participants and 2 data acquisition sessions performed during 2 separated days. The animation presented here shows an example of gate cycles recorded by initial tracking system available in our department. Thank you for your attention. If you have got any additional questions, do not hesitate to ask me.
Okay, thank you very much. Any questions from the on-site participants? Yes, there is one. Okay, Dr. Kopczyński.
I'm sorry.
No, don't apologize. No.
Alexander, thank you very much for showing your research results. I have the question related to, let's say, precision of the sensors that should be used for gathering the data for the gate cycles. Is it something what needs to have the high rate of precision? Or for example, some usable data could be taken by the, let's say, set of the smartphones that are attached to the different parts of the body?
Okay, so thank you for your question. As I mentioned in the presentation, we used only one sensor that was attached to the leg. So this kind of experiment could be easily replicated on a transformer that would be can be implemented in a smartphone. So the measurement quality or the accuracy of the sensor is not very important in such a case. What is more, the sensor that we have got in our system is similar quality that is used in the modern smartphones. So this is not a very important factor, in my opinion.
Okay, any other questions? Perhaps there are any questions from the remote participants. If so, please indicate this. Okay, there are no questions, so thank you very much. And let me close the morning Cisim 2021 session. We'll have a coffee break now, after which at 11:30 we'll start our last session. So 11:30 we will resume our proceedings. So thank you very much.
Hello. I would like to welcome all of you on the second session of Sunday. On the second session, we will have 4 presentations. And first presentation will be delivered by Aleksandra Pawlicka, Michał Choraś, Marcin Przydyszewski, Lauren Belmont, Rafał Kozik, and Konstantin Demestichas. And the paper will be entitled, Why do law enforcement agencies need AI for analyzing big data?
Hello, my name is Aleksandra Pawlicka. I work for ITTI from Poznań, Poland. Today I'm going to deploy some arguments in favor of using AI in the daily tasks of the law enforcement. So, why do law enforcement agencies need AI for analyzing big data? At ITTI, we are more or less a software house with an R&D twist. We could be described as a small to medium enterprise made up of about 100 individuals with a range of certificates across the board, from management through enterprise architecture to information security.
I have a request. If there is the possibility, please turn on your cameras so we could see each other. Thank you.
We mainly deal with the development of customized software solutions and innovative applications, along with applied R&D. For our work in the European Commission framework programs, we have received the Crystal Brussels Prize 5 times and the prize for outstanding performance in R&D projects for the EDA. We're the members of a number of significant international bodies. This is the team that was included in this project. Michał and Rafał lead the team, supported by postdocs like Marek and me, and software engineers Marcin and Damian. We have experience in a wide range of EU-funded projects. Our areas of interest are machine learning and pattern recognition, data mining and analytics, various aspects of cybersecurity, etc., etc. The work I'm going to discuss was done in a Horizon 2020 project called Magneto. The shortest possible description of what it is about is fighting against crime and terrorism. What Magneto does is it augments the capacity of law enforcement agencies, or LEAs, to deal with extreme volumes and diversity of data in order to accomplish highly efficient crime prevention and investigation. We are a consortium made up of 23 partners from 10 EU countries. It includes universities such as the University of Valencia, tech companies, SMEs like ITTI, law firms, and of course a long list of law enforcement agencies. Magneto addresses significant needs of law enforcement agencies in their fight against terrorism and organized crime, related to the massive volumes, heterogeneity, and fragmentation of the data that officers have to analyze for the prevention, investigation, and prosecution of criminal offenses. These needs have been identified after consulting with 11 different European LEAs, members of the Magneto Consortium. In response, Magneto empowers LEAs with superior crime analysis, prevention and investigation capabilities by researching and providing tailored solutions and tools based on sophisticated knowledge representation, advanced semantic reasoning, and augmented intelligence, well integrated in a common modular platform with open interfaces. LEAs have determined the 5 most significant use cases in which there occur problems with processing large volumes of heterogeneous information: crime against persons and property, economic organized crime, prevention and investigation of terrorist attacks, parallel illegal economic circuits of organized crime, and identity crime. In order to address the expressed needs of LEAs, it has been determined that the most optimal and effective array of tools to be employed in order to discover new, unsuspected relations within large datasets in an automatic way should comprise of advanced correlation engine. This technology would enable automatic finding of new relations within large datasets, the relations that have not been suspected before, sophisticated representational model, in order to represent knowledge in an open, standardized manner. This would lead to discovering the relations and enabling interoperability. Evidence collection platform. Such a platform would be used for mining heterogeneous data and indexing multimedia content. Thus, it would become available for the processing at next stages. Threat prediction engine by semantic reasoning. This technology would enable analyzing trends and assessing the levels of threat. And augmented intelligence tools. They would be applied so as to deliver human-machine interfaces that are both immersive and interactive and enhance the awareness of the situation. The Magneto solution has been implemented utilizing an architecture of a modular character. This lets the platform guarantee distributed and scalable services. Each module is isolated within a Docker container. Such a method ensures optimizing the process of development, whilst each development group simply has to deal with the services assigned to them. The decision to apply the microservices architectural style in the Magneto framework proves advantageous owing to the number of features it brings, such as integrating the new services functionalities into the architecture with ease, integration tests becoming simpler, development updates becoming simpler concerning exclusively the relevant elements of an application, or making the application be more resilient and stable, being immune to a single point of failure. The figure presents the logical and technical architecture of the platform and the elements which aim at addressing the needs of law enforcement agencies. The fundamental concept of a successful AI-based solution for LEAs is to establish a crime prevention and investigation scheme that will be perpetually self-improving. the heterogeneous data flows within the scheme are to be changed into knowledge bases in accordance with a complex representational model. Then they are processed and fused by means of semantic technologies. HMIs represent their results and significance in a visual manner. Such interfaces enable decision-making that is timely and accurate, they make it possible to extract court-proof evidence, and they also allow for situational awareness. Now you can see some pictures showing a fragment of the platform in use. Since most of the work done for the law enforcement agencies is classified, I can't show you much, I'm afraid. Here you can see some of the visual analytics the platform provides when used for call detail record analysis. And here you can see how the call detail records allow pinpointing the individual's location on the map. It must also be emphasized that the Magneto platform, though being a strictly technical solution, is human-centered too. This is achieved by ensuring compliance with the national and EU laws such as the GDPR. On top of that, the platform has been designed with ethics in mind. Then, the AI solutions applied in the platform's architecture are not of the black box nature, that is, their decisions have to be explainable. If these issues have sparked your interest, here are some papers on the matter written by our team. All in all, the successful application of an innovative AI-based solution will vastly enhance the way law enforcement agencies function nowadays, and the Magneto platform has the potential to do it, as for law enforcement agencies, data analytics can help officers lower crime rates and expand social services. Moreover, the actual impact of the solution might be far greater, as the outcomes of the Magneto project have already proved useful as part of other solutions. For example, the prevision, so the prediction and visual intelligence for security information project. Lastly, the ongoing pandemic has made many jobs remote, so as to try to slow the spread of the disease down. Thus, implementing digital software may be the main factor to allow law enforcement agencies continue performing their tasks without risking their employees' lives. Undoubtedly, the improvement in crime investigation and prevention, as well as in the fight against terrorism, will contribute to a more secure, citizen-friendly Europe. Thank you for your attention.
Thank you very much for delivering the presentation and sharing your research results. It's time for the questions now. So are there any questions from the on-site participants? Okay, we have one.
Thank you very much. This is really impressive. Now my question is, what are the biggest challenges during the development or enrollment of the projects? I mean, there are so many issues, but what are the biggest ones?
Well, can you hear me?
Yes.
So thank you very much for this question. I think, and I hope that the team members will back me up here, but I think that one of the most important and significant challenges here is, as always, getting the data, because here we work on LEA's data, and most of it, if not all, is classified, is very sensitive, and is very often crime related. So, as you know, it is usually the more data, the better. And here, sometimes it's the case that the access is very, very difficult here.
And Alexander, Michał Choresz here. The other one, if you can hear me well, is that here in Magneto we decided that the law enforcement will have the solution on-site. On-site means they need to buy equipment, which means public tenders, which means lots of wasted time from the research perspective. But also it means the deployment, the classified data on their premises. So it's not easy. So in some of the other projects now we shift into this model of having such solutions for law enforcement in the cloud, so as the service. Of course, with appropriate authentication, login, GDPR and stuff like that, but it's also one of those aspects that are not only technical, but also organizational.
Thank you very much. Are there any other questions? On site? No? Maybe online participants? Okay, I don't see any hands raised. So thank you very much for the answers.
Thank you very much.
Okay, we can move to the second presentation on the second session. It is the paper entitled Raspberry Pi-based device for finger veins collection and the image processing-based method for minutia extraction. And the paper is authored by Maciej Szymkowski.
Ladies and gentlemen, it is my pleasure to welcome you on my presentation. My name is Maciej Szymkowski and I am representative of Białystok University of Technology, Faculty of Computer Science. Today, I would like to present you the results of the research published in the paper entitled Raspberry Pi-based device for finger veins collection and the image processing-based method for minutia extraction. In this slide, you can see the core elements of my today presentation. At the beginning, I would like to provide you some details related to the fact why I have conducted this research. Then, I will present you the recent state of the art. In the further step, I will also say a couple of words about my proposed solution. Also, some details will be provided in the terms of conducted experiments, whilst at the end of my presentation I will also tell you a little bit about the future plans and conclusions. However, let's start from the main aim of the conducted research. So, at the beginning, it has to be claimed that in novel approaches related to biometrics, multimodal biometrics is one of the core concepts. In this fact, it is related to the fact that multimodal biometrics can give us much higher accuracy than in comparison to traditional biometrics methods when we will use only one feature. In fact, it is why I started this research. This is only a part of much bigger project connected with multimodal biometrics. This time I would like to propose my own device for finger veins collection. It is based on single board computer, and I will also tell you which of them were tested during experimental phase. However, it is not the only part of this research. Of course, device is a core concept. However, also the image processing based method was proposed to extract minutia from finger veins. In fact, minutia is mostly used in the process of fingerprint recognition. However, also, as you will see in my presentation, it can be used directly in finger veins. Right now, I would like to tell you a little bit about recent approaches. As you can see in the slide, there are only 5 works. However, I would like to select the 5 most important ones. Why these ones? Why I selected these 5 works? In fact, most of them are related to some novel approaches, to some novel ideas. As you can see, most of them uses artificial intelligence and machine learning for recognition of the veins. In fact, for example, in the first work, we can see fully convolutional neural network. In the second of them, we can see deep learning techniques. In the third, we will see the device that will be used to collect the finger veins. In the fourth one, we see different features. So in this case, curvature in radian space. In the fifth of them, we will see once again convolutional neural networks. These works were selected because they present some novel concepts, and mostly they are also using the novel ideas as convolutional neural networks, or they are present the hardware. But there is one major thing that has to be pointed out. In the case of most of them, at least in only one of them, is hardware presented. However, in the four of these works, we can see only an algorithmic approach, only a software development approach. However, there are no information about the device. Of course, someone can say, okay, why should we work out a new device? On the market, we can find out many different devices for finger veins collection. However, it is also has to be claimed that the price of them is really high. It is one disadvantage. However, the second of them is that they are not related to finger, they are related to hand. And it is really hard to collect finger veins with the device that should be used for hand veins collection. So it is why we also have to think about and have to keep in mind that finger veins is completely different process. Collection of finger veins is completely different process than this related to hand veins. And it is why we have to prepare our own device. Right now, I would like to provide you some details related to the proposed solution. In this slide, you can see two images. They are showing the idea that lies behind my own device. In fact, both these pictures were taken from one of the publications that was published in the literature. Why I use them? Because they present the core concept of my device. In the left picture, we can see near-infrared light that is used in the device. By these diodes, we can lighten up our veins and make them visible. Of course, we also have to think about precise image sensor. In this case, in my terms, in my device, it is a camera. Of course, during experimental phase, many different cameras were taken into consideration. All of them will be listed in the further part of this presentation. However, in the right picture, we can see the device, and in fact, it is nearly similar to the one that I propose. So we have to place our finger, and then the finger veins are collected. In my system is based on Raspberry Pi. As you can see, we have here a camera, night vision camera, that enables us to collect the finger veins, and infrared LEDs that can enlighten the veins. Of course, the finger has to be placed between the camera and infrared LEDs. As you can see, this is the whole system, the really easy system, but it is based on one single board computer, Raspberry Pi. All worked out software was proposed in Python programming language. And I would like right now to show you the results that were obtained with the proposed solution. The first picture from the left shows the sample, the original sample. As you can see, here we have a couple of veins. We can see them by our eyes. However, we still need to work out the whole solution that will enable us to collect the minutiae. So, the second image from the left shows us the finger veins after preprocessing stage. The third one is after binarization and after additional operations by which additional noise was removed. In this case, we used, for example, median filtering and additional denoising filters. And finally, the last image, the first from the right, is the image after thinning. In this case, it was used K3M method, and also minutiae detection. As you can see, only two types of minutiae were taken into consideration. These are ridge endings and ridge bifurcations, so the most popular ones. Of course, I would like also to claim that in the scope of this work, there is no physical, no programmatical part related to vector creation and identity recognition. This will be the further part of the work related to this field. I would like also to tell you a little bit about the conducted experiments. The main point of this research was related to creation of the device and image processing based method for minutia extraction. In the case of the first one of the device, the core experiments were related to the construction. So different number of diodes were used, different types of them was also considered, and moreover also different types of cameras were tested. We have to be 100% sure that this configuration of the device is the best one, is the most precise one. So it is why different cameras and different LEDs were considered, different number of them. And the most precise results were observed when Arducam OV5647 was used, and moreover when 3 LED diodes were placed in our device. Moreover, also different single-board computers were considered, not only Raspberry Pi, but also Latte Panda and NanoPi. But once again, the easiest one process of software development was observed in the case of Raspberry Pi, and it is why this single-board computer was used. Moreover, it can guarantee satisfactory accuracy and also high speed of processing. In the second part of experiments, we also tested different image processing algorithms, for example, canny edge detection. Right now, I would like to move on to conclusions and future work. I said that I selected finger veins. And why? Because this trait is highly distinguishable, and moreover, it can be easily obtained, as you can see. What is more, there is no possibility that it will be changed during our life. Of course, we are not thinking about different accidents or different situations. In the case of normal, standard life, this trait should not be changed. Moreover, what is interesting in the terms of the research? In this case, we tested different circuits and different methods just to obtain the most precise and the most accurate results. What is more, these results that I have shown us that the worked out algorithm and device are efficient and accurate. Moreover, it can be also practically used in the real biometrics system. At the end, I would like also to say a couple of words related to acknowledgement. I am really grateful for my thesis supervisor, Professor Khalid Said, for his continuous support and all advice given during this algorithm construction. What is more, I am also very grateful to Professor Said for verification of the proposed approach. Moreover, this work was funded by the Resources for Research by the Ministry of Science and Higher Education in Poland, but they were granted by Białystok University of Technology. Thank you for your attention. I'm waiting for the questions.
Thank you very much for this interesting presentation. We have now some time for the questions. So let's start from the on-site participants. Are there any questions? Yes, we see one person.
Thank you very much for very interesting presentation. I have one question about the lighting, about the source of the light. Why have you chosen the latte-emitted diodes to this device? Have you think about other sources useness in this device. Yes, because I think the light emitted diodes has a very low power. Maybe you should use something like flash source with more energy. I don't know, but such a question arises, so
okay,
please answer.
Thank you
Thank
very
you.
much for the interesting question. In fact, I have selected LED diodes, infrared LED diodes, because they can really easily enlighten our veins. And in fact, it is also really easy to connect them to the Raspberry Pi. We do not need any additional source of energy. So it is why, and also during the literature review, I also observed that in the many cases, these LEDs were used just to enlighten the veins, and it is why they were selected. Of course, I have also tested even with the simple flash from the phone, but then even in the darkest places, in the case of this kind of box, the veins were not observed. So it is why these LEDs were selected.
Maybe you should think about the veins of the LEDs emitting diodes. Have you chosen the LEDs with chosen wave?
Well, yeah, this is why infrared LEDs were used, because when I tested also the red ones, green and blue, the veins were not clearly observable, even by human eye. So during the tests, it was also not observable, even with the greatest camera, this Arducam that was finally used in the final device.
Thank you very much.
Thank you.
Thank you for the questions. Yes, we see the second question on the on-site.
Congratulations on developing this, inventing and developing this device. I was just wondering how repeatable the measurements are with your device.
Well, in fact, in the whole device, we also have a specific place that you have to put your finger. So this is clearly impossible just to move it or to place it in the other way. So in fact, also during the test, I considered, for example, that I will place my finger not directly, not in the center place, but for example, on the left or right. But this is why we also, with Professor Khalid Said, we also discussed it during our meetings, and it is why also a specific place was used to just to place the finger in the same way.
Okay, thank you.
Thank you very much.
Thank you.
I can only confirm what was said, mentioned here, and discussed.
Okay, thank you very much, Professor, for the confirmation. Any other questions from the on-site participants? I don't see any. And the online participants would like to ask? No hands raised, so thank you very much for the answer. Now we have time for the third presentation. It is the paper entitled Typing Pattern Analysis for Fake Profile Detection in Social Media. That was made by Tapali Batasali and Khalid Said. So we can start.
A very good morning to all the dignitaries, participants, organizers present here. Myself, Dr. Topulina Bhattashali, currently working as Assistant Professor in St. Xavier's College Autonomous, Kolkata. And my co-author is one of my PhD supervisor, Professor Khalid Said. My presentation topic is Typing Pattern Analysis for Fake Profile Detection in Social Media. Nowadays, the usage of social media is growing day by day, and with rapid growth of social media usage, there are a number of challenges coming up. So what are the challenges? one user may create multiple profiles or multiple users can create different profiles for a single identity in social network. Fake users often create profiles of targeted victims either to retrieve any confidential information about victim or misuse victim's identity to confuse others within the network or negatively affect victim's reputation. Malicious users often send friend requests to the users from victim's friend list as if request comes from genuine user. Fake profiles are created to ask for financial assistance or any other facilities from the users in the social network. Sometimes genuine user's profile has been hacked in the middle of a session to misuse the profile. There are a number of solutions, number of research works are going on all over the world, but among these behavioral biometric methods seems to provide better solution. Why? It is better to identify fake profiles while users use desktop, laptop or touch devices to interact in social network. Users' typing pattern tends to produce consistent results over time while being less disruptive to users' experience. In one-time login, resources are available to that user until user exits or session terminates. Consequently, any user can also access system resource in the middle of valid session. So this may lead to session hijacking. Here, user's identity needs to be verified iteratively. What is the aim of this research work? Differentiation between fake profile and genuine profile in social media. Identification of genuine profile hijacking by intruders in the middle of a session. Here focus is on how accurately fake profiles can be detected and how fast and accurately social media profile hijacking can be detected. Major contribution of this research work. A model is proposed here that is known as DeepID, which is a multi-view multi-class neural network framework to recognize user based on keystroke, mouse click and touch stroke patterns. Design of proposed model is based on simple category of deep learning neural network. This makes it easy to interpret and modify the model based on the scenarios. Background. So deep learning or deep neural network is a subset of machine learning algorithms which is used to model high-level abstractions in data. Recurrent neural network or RNN and convolutional neural network CNN are the two major categories in deep neural network. RNN is frequently used to solve problems in natural language processing, whereas CNN is used in computer vision areas. Long short-term memory network LSTM is a type of RNN which can learn long-term dependencies. RNN can only capture the relationship between recent typing information to use it for prediction. LSTM is more effective in typing pattern analysis. However, it is a complex structure that may cause high overhead. Gated recurrent unit or GRU can produce similar or better result in typing pattern analysis compared to LSTM. And as it uses less parameter, structure of GRU is simple. So it is quite feasible. GRU is considered here as each unit in the network can easily remember specific patterns in input stream for a long time. That's why GRU is preferred here. Any important patterns can be overwritten by update gate. If one view or one specific type of pattern is selected, then single view, single tasking deep learning model can be designed with GRU. In that case, GRU can take normalized typing dataset as input and produces final output vector to recognize user. In DeepID model, there are a number of features. So single view, single class framework is extended to multi-view, multi-class framework to consider keystroke, mouse click and touch stroke patterns. So this is the proposed DeepID model. The stages of this model. First, data collection is there. Then there is the multi-view data generation, that is N cross M view from keystroke, mouse click and touch stroke. Then multi-view, multi-class learning. So multi-view data set is there. From there multiple views can be constructed, that is view 1 cross 1, view up to view N cross M. And accordingly number of GRU units can be designed and there are some hidden concatenation. and finally multi-class output can be produced. So this is basically MVMC learning with deep structure evaluation, and this is one variation of RNN. So when we consider the steps of fake profile detection, we need to consider 4 main steps. In step 1, raw typing data collected from 50 volunteers using social media profiles. Profiles of 5 volunteers are considered as genuine. For each genuine profile, 9 fake profiles were created to detect typing pattern of fake users in real time against 1 genuine identity. It was continued for 6 weeks. In step 2, multi-view dataset was prepared from the collected information for user recognition. In step 3, multi-view data was modeled through a deep learning structure to perform multi-view multi-class learning. In step 4, performance of the proposed MVMC learning with deep structure is evaluated in comparison with traditional machine learning algorithms like random forest, support vector machine, which are popularly used in case of classification. Data collection. So data collection process involves 50 volunteers who are experienced enough to use Facebook like social media from any devices like desktops, laptops, smartphones, tablets, who have good internet connection, who are active users in social media by typing or uploading story, clicking stickers, doing chat, scrolling posts, using touch gestures frequently during their login session. So we have considered 2 cases. Case 1, collect data from 50 volunteers and divide them into 5 groups. In each group, 9 users create 9 fake profiles against 1 genuine user, and their typing patterns are considered for classification purpose. In case 2, 5 volunteers' profiles are considered as genuine and data are collected when other volunteers enter into genuine profiles during their login sessions. Data processing. Users use social media profile either from desktop, laptop, smartphone or tablet. Keystroke and mouse click patterns are considered for desktops and laptops, whereas touch gestures are considered for smartphones and tablets. Collected data are processed to generate N cross M multi-view dataset. Here N represents view and M represents modality. Modalities are keystroke, mouse click, touch stroke. Keystroke views are created from the temporal features of N graph. It represents the time difference between key down of first character and key up of last character until space is encountered, divided by number of characters. So average N graphs are created for all possible combination of characters from the keyboard. Continuous movement of cursor has been recorded until mouse button is released. Views are created based on duration of click and change of position of cursor in X and Y direction with respect to time like dx dt and dy dt. Touch stroke views are created based on virtual stroke, zoom stroke, slide stroke, pin stroke, writing stroke, tap strokes. And outliers in the process data have been discarded. Multi-view multi-class learning. So here defined views of 3 defined modalities have been considered. Each view contains defined number of samples and defined number of features. Fusion method is used to combine datasets of defined views. It is difficult to build single view dataset due to defined number of features in each view of each session. To avoid information loss, multiple views are considered separately instead of concatenation. Multi-view multi-class learning can help to improve the performance for profile recognition. It can be easily determined that which view can mostly contribute to the identity detection process. Dataset is separated into multiple views. Bidirectional recurrent neural network along with GRU is used to build hidden layers for each view. Softmax function is used to perform multiple classifications in output layer. Performance of each view is evaluated. Last layer information from each GRU BRNN model is concatenated. This concatenated layer contains all information for accurate authentication. So use of GRU in deep ID model removes the problem of heterogeneity in the time series of each view and improves the performance of prediction. So these are the fake profile detection metrics. Recall, true positive plus false negative. Precision equals to true negative by false positive plus true negative. F1, 2 into precision into recall divided by precision plus recall. accuracy equals to true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. So this is the analysis part where it is plotted duration versus multiple views for 5 users, and multiple views are keystroke n-graph, mouse click view 1, mouse click view 2, touchstroke view 1, touchstroke view 2 and touchstroke view 3. So this is the sample one to display that users can be accurately classified based on the timing duration and multiple views. This is the comparative analysis of deep ID model accuracy. So several classifiers have been considered, and users are grouped into 5 users, 10 users and 45 users. 2 popularly used machine learning algorithms are used here, support vector machine and random forest, and also it is considered for single view and then deep ID model. So there is a comparative analysis based on the accuracy, and it is showing the deep ID model performs better compared to the other models. This is again the comparative analysis of F1 of deep ID model based on the classifiers, existing classifiers versus deep ID model, and the number of users are same, 5 users, 10 users and 45 users. In that case the result is also same. The deep ID model performs best compared to the other classifiers mentioned here. Next one is how to detect social media profile hijacking. So traditional time related metrics cannot be used here because it is the iterative process where user need to identify the imposter. So what are the metrics we can consider here? 4 metrics we can consider here. One is time to true reject, one is validity. So what is time to true reject? This is basically the difference between the TF-IMP and TR-IMP, where TF-IMP represents timestamp of first activity of fake user and TR-IMP represents timestamp when system truly rejects that intruder or fake user. If system fails to reject the fake user truly, TTR moves to infinity. TTR should be less than a vulnerability frame. What is vulnerability frame? This is the minimum time to negatively affect social media profile. So within that vulnerability frame, the system needs to reject the fake profile. Otherwise, it can negatively affect the social media. Next one is validity, that is the small t divided by capital T, where small t is the duration when genuine user is active in social media platform and capital T is the login session of that user in social media. So how long the valid user can access the login session. Next metric is probability time to true reject, PTTR. If system takes longer time than vulnerability frame, then PTTR is less than 1, which is tolerable. But if system always fails to reject intruders or fake users within vulnerability frame, then PTTR equals to 0, which is not tolerable. Next one is validity acceptability characteristic curve or VAC. This is basically a curve of validity versus PTTR gives rise to validity acceptability characteristic curve. This is similar to ROC. So area under VAC is used to measure the overall performance of profile hijacking detection procedure. From this, we can see this from here, the analysis part, the time to detect genuine profile hijacking, duration versus session, that is the time to true reject, and within the vulnerability frame, all the fake profiles have been detected. This is the validity of genuine users in social media. So login time, valid time. So how long valid user can access this valid time. So users at different session versus duration has been plotted here. And this is the validity acceptability curve where the PTTR versus validity is plotted, and the area under this curve represents the efficiency of profile hijacking detection. So in the conclusion, we can say that Deep ID model is proposed to detect fake profiles on social media. It does not need data preprocessing or manual feature selection and extraction compared to most of the machine learning classifiers from the literature. Multi-view, multi-class learning makes it capable to classify all features separately and do fusion to take final decision. Proposed model can detect fake profiles on social media with utmost accuracy. It can also quickly identify profile hijacking within a session. If all the TTR values are within vulnerability frames, risk in social media can be reduced. Multiple views of dataset along with GRU in deep learning network can improve identification performance. Capability and performance of Deep ID model can be further extended to solve real-life problems with large dataset from social media. So this is the acknowledgement part. Poland. This is few of the references. Thank you for listening my presentation.
Thank you very much for delivering the presentation. Just to confirm, is Tapalina with us? Yes or no? Okay, so we don't see Tapalina here in the list of the participants. So in case that you have any questions, please send them directly to organizers. The last presentation that we have during this session is the presentation entitled Toward a Unique IoT Network via Single Sign-On Protocol and Message Queue. And this work is authored by Nguyen Tran Lam, Nguyen An, Vo Hong Kan, Luong Hoang Hung, Nguyen Huyn Tuan Koi, Dao An Tuan, and Huan Son Ha. So we can start.
Ladies and gentlemen, my name is Lam Nguyen and I will present my paper which has the title Toward a Unique IoT Network via Single Sign-On Protocol and Message Queue. My outline includes 6 sections: Introduction, Related Work, IoT platform proposal design, implementation, evaluation, and conclusion. Go to part 1, Introduction. In part 1, we will consider some points. Nowadays, IoT technology is very important because it has grown rapidly and applied to many fields. For example, smart city, healthcare, supply chain, industry, and agriculture. According to the estimate, there will be 75 billion devices IoT connected by 2025. There are many IoT protocols, but MQTT protocol is the most popular for IoT because it has the high transmission speed, and this is a live protocol, so it's very suitable for the limited resource device. In addition, IoT network has many organizations with different ways of managing user and different message structure, so it is very difficult to manage and exchange information between organizations. To address this problem, we propose the IoT platform which able to improve MQTT security mechanism and easy manage user and exchange information between organizations. We go to part 2, Creative Work. In part 2, we summarize some research paper. Power incremental add-on UOR protocol to enable access control in MQTT protocol. Benjamin Azi add-on UOR and introduce the concept of personal cloud middleware to manage user registration and IoT device. Rosie Kato add-on use Kafka Message Queue to as the sandbox system between MQTT broker and the rest of IoT system. This helps to improve the performance of the system and easily to scalability. And finally, Amos Hugo add-on combine Kafka Message Queue and MQTT for his intelligent transport system. We go to part 3, design of IoT platform. You can see figure 1 illustrate our architecture of IoT platform. Our architecture divides into two parts. Part 1 is system architecture. System architecture include two or many organizations. Each organization has the same component include the MQTT broker deploy a cluster with one broker for external communication and remain the broker for local communication, the single sign-on server, the single sign-on database, and the Kafka MySQL. Part 2 is software architecture. Software architecture include first, user are who use IoT service. Second, the thing is the physical device or application owned by the user. And finally, the channel is logical information for managing where users public message to thing, and the thing will supply to the channel to receive message. With software architecture, we will build the roll-up concept. That's only the user to send or receive message on his or her thing when those things are mapped to the channel owned by the user. You can see figure 2 illustrates the process of public message between two organizations. This process will follow to this step. Step 1, user or publisher send the message to MQTT proxy instead of direct to the MQTT external broker. Each user possesses their channel, for example, the public send message and the public receive message. Each outgoing message has content OR token, and this token will be authenticated by single sign-on proxy. After authenticate user token, single sign-on proxy also check the user role. User role will involve to the permission of the user. For example, this user is allowed to send message or only receive message, or is this user allowed to send message on this channel or not. After checking user validity and ground, message will be sent to the MQTT broker and finally reach the Kafka MySQL. The receiver who are authenticate and check user role by single sign-on proxy can receive message via MQTT proxy. To part 4, implementation of IoT platform proposal. You can see figure 3 illustrate user organization A model 3. In this model, we have 3 definitions, include root user, parent user, and child user. The root user plays the role as IoT network administration. The parent user can create, delete, or enable disable child user. Child user connect with the parent user via user parent ID attribute. If one user has started is disable, his or her can integrate to IoT platform. This helps with isolate the group of users or even organization from IoT network when the system is attacked. We go to part 5, evaluation. You can see figure 4 illustrate our evaluation model. Our model includes 3 components: organization 1, organization 2, and management central. We deploy this model on the several servers are listed in table 1. In organization 1, we have 3 components: 1 broker for external communication, 1 broker for internal communication, and API service. The organization 2 is similar to organization 1. and the management central include single sign-on server, database, and Kafka message queue. In scenario 1, we evaluate local communication ability with and without using IoT platform proposal. We simulate concurrent user who send message by using Zimeter software. Then we increase the number of CCU and record the highest number of CCU without system failure. The test results are illustrated in table 2. And we have the highest CCU with IoT platform is 400 and the highest CCU without IoT platform is 500. In scenario 2, we evaluate public communication between two organizations. Similar to scenario 1, we simulate user send message by using Zimeter software and record the highest CCU without system failure. The test results are shown in table 3, and we have the highest CCU without system failure is 140. We go to final part, conclusion. In this research, we try to reach some target. First, we improve the security of MQTT protocol. The second, we allow strict management of user, thing, and channel. The third, we allow to easy communicate between two or many organizations. And the final, our IoT proposal ensure don't lose message when connection is broken in comparison with MQTT protocol only because this protocol have no buffering mechanism. For the future research, we will consider brockerless architecture to avoid single failure point in comparison with brokering architecture using MQTT. And we also consider decentralized authentication. Thank you.
Thank you very much for presentation, for the interesting research that you have shared with us. Are there any questions related to the topic that was covered from the on-site participants? Okay, I don't see any hands raised. From the online participants, is someone who would like to ask the question? Also no question. So it means that the presentation was so good that was self-explainable. So thank you very much for your effort. And now we'll have some break until 2 p.m. where we will close the conference. So see you soon. Thank you very much.
Welcome to our last sad session, closing session. It's always sad to say goodbye, so we'll never say goodbye. We will say only for now. So before closing, before the physical closing, let us listen to the word of Mr. President, Dr. Tito Cisim, the Minister of Technology, Science and Education in Colombia, who was director of the Coast University in Barranquilla before he became the minister. And from that time, our cooperation is taking place. He promised to send his word during the conference, and he did. The word will be read by Professor Dionisio Neira. Please.
Greetings to everyone. On behalf of Mr. Tito Cisim, Minister of Science of the Republic of Colombia and former rector of Universidad de la Costa, thank you for accepting the Cisim 2021 Organization Committee invitation. We extend an affectionate greeting to Professor Khalid Said. We have been working together from Universidad de la Costa in Barranquilla, Colombia. We also extend an affectionate greeting to Professor Marta Kosior Kasberuk, Rector of Białystok University of Technology. We also appreciate the efforts that Professor Said and Professor Kosior Kasberuk are leading to sign cooperation and research agreements between the Ministry of Science of the Republic of Colombia, Białystok University of Technology, and the Ministry of Science of the Republic of Poland. It is an honor for us to have participated in the previous versions of the Cisim conferences since 2018. We have been able to strengthen and motivate our researchers to access research networks at an international level. It is also a great pleasure and honor to organize the 2022 conference in Barranquilla, Colombia. The conference will be held at Universidad de la Costa, which has more than 11,000 students in the departments of Natural and Exact Sciences, Civil and Environmental Engineering, Energy, Business Sciences, Productivity and Innovation, Social Sciences, Architecture and Design, Computer Science and Electronics, Law and Political Science. Additionally, we have 15 master's programs in all these areas and 7 doctoral programs, including innovation and information and communication technologies. Universidad de la Costa was founded in 1975 and has been training professionals in engineering, psychology, law education, and administrative sciences for more than 40 years. In all these years, the university has been working on the continuous improvement of its facilities and the formation of its human resources. This improvement process has helped the institution to increase the capabilities of the institution's graduates as well as the institutional rank in research. According to most recent studies, these efforts have allowed that the institution's graduates are among those who manage to find employment in the city faster. Concerning the university's facilities in recent years, the institution has made significant investments in this regard. It currently has 3 conference rooms, one for 200 people and another 2 for 90 people. In these conference rooms, the Cisim 2022 conference will be held. The university also has a new building with biology, chemistry, quality, production, electronics, industrial safety, innovation, electricity, simulation, and logistic laboratories. This new building has implied a significant leap in the research and innovation capabilities of the institution. Multiple patents registered by the university in recent years evidence the institutional improvement in research. Additionally, there is a postgraduate studies building which has facilitated interaction with the production and service sector of the region, allowing the development and formulation of research and improvement projects in different companies in the city. Last but not least, the university, as part of its integral student training project, provides spaces in which students can relax and innovate. In this sense, the institution has also created a students' welfare department that permanently monitors students' performance and provides psychological support when student psychological risk is detected. I take this opportunity to invite you and your colleagues to participate in the 2022 conference in Barranquilla. Barranquilla is the capital district of Atlántico Department in Colombia. It is located near the Caribbean Sea and is the largest city and third port in the northern Caribbean coast region. As of 2019, it has a population of 2.2 million people, making it Colombia's fourth most populous municipality after Bogota, Medellin, and Cali. Barranquilla lies strategically next to the delta of the Magdalena River from its mouth at the Caribbean Sea, serving as a port for the river and maritime transportation within Colombia. It is also the leading economic center of the Atlántico district in Colombia. In July, the city has summer weather with temperatures around 28 degrees and soft breeze. The city was legally established as a town on April 7, 1813, although it dates from 1629. It grew into an important port, serving as a destination for immigrants from Europe, especially during and immediately after World War I and World War II, when waves of additional immigrants from the Middle East and Asia arrived. Barranquilla became Colombia's principal port, and with its level of industrialization and modernity earned the city nickname Colombia's Golden Gate. Barranquilla has hosted the 2018 Central American and Caribbean Games and will host the 2027 Pan American Games. The city is home to one of Colombia's most important folk and cultural festivals, the Carnival of Barranquilla, which was declared a national cultural heritage by the Congress of Colombia in 2001 and recognized by UNESCO in 2003. The city has become a pioneer in different aspects. For example, the Ernesto Cortizos International Airport, built in Barranquilla in 1919, was the first airport in South America. Universidad de la Costa will support the 2022 conference in coordination with local authorities to ensure the safety of the attendees. We are coordinated with hotels and transportation companies, the best options for accommodation and transportation from the airport to the hotel for greater peace of mind of all the attendees to the conference. In the same way, we are organizing a tour at the Magdalena River to have contact with the local traditions and history. In this way, we intend to strengthen exchanges at the research level and at the cultural level that ultimately significantly impact our society. I hope you enjoyed this conference. I hope you have enjoyed this conference of the year 2021, and we look forward to you with open arms in July 2022 in the city of Barranquilla. Thank you very much.
Thank you very much, dear Dionisio, for your presentation, and please convey our sincere thanks to Mr. Minister for the kind words, and we wish him quick recovery. Okay, so we hope that Cisim 2022 will be another success next year in Barranquilla. And all of you, on-site and online, are invited to join us, with or without a paper, because I cannot guarantee its acceptance. Thank you very much once again, and let's go to the second part of the closing session, which is, as I said, the goodbye words. Let me at the end say thank you, first of all, to all of you. If I want to mention the names, I would need an hour to read the whole list. So let me, on behalf of all of you, dear participants, contributors, on-site and online, thank particularly those who took part with us in the conference, who presented their works or who contributed to them. Thanks to the chairs of the sessions. Thanks to those who tried to make the conference a dynamic event. Let me, and I think you agree with me, thank in particular Dr. Kopczynski, because he asked almost every single presenter, on-site or online. And not only, he didn't ask only to ask, but he asked really constructive questions. Thank you. Okay, so now it's time maybe we say also on behalf of all of you, thank you to the main assistants who helped us here, who helped all of the session chairs in conducting the presentations. I mean my assistants, Mr. Maciej Szymkowski and Mr. Alexander Sawicki. They proved to be very good assistants, not only during the lecture, but also during the conference, as you noticed. They were from the beginning until the end with us, helping us, trying their best. And at the end, let me, on behalf of all also, let me thank the transmission team with Mr. Pavel as its head and leader. All of them tried their best, as those who are on site noticed, I'm sure, noticed their role. They were controlling, doing their best. Yesterday, even at night, they tried to check if everything was ready for today's closing session. Thank you very much, Mr. Pavel. Thank you very much, friends. If they go with us to Barranquilla, I would like to invite them to make the transmission from there too. Okay, thank you very much. And now maybe we'll have a photograph with all on-site and online. So on-site, maybe you come here, or in a way that Pavel can show you, just gather in one place, maybe the first line, or here, as you like, so that we can all be there. But please, to those who are online, I request you to switch on your cameras, please. Yeah, some of our friends who were active afternoon, because they were active afternoon, I mean our afternoon. For them, it was early morning. So now they are sleeping, unfortunately. So we will not awake them to get out of the bed just to show their smile. We hope we will keep it for the future. Okay, so a photograph, maybe? Yeah, join us. All of you join us. Come. Okay.